Good evening. My name is Shahzeb Ahmed, and today I'll be presenting my individual reflection and analysis for our group project titled Bank Marketing Campaign Analytics. The project was completed for the unit Business Analytics and Artificial Intelligence and focuses on how predictive analytics and machine learning techniques can be used to help a bank identify which clients are most likely to subscribe to a term deposit after a marketing campaign. In this presentation, I'll walk you through the project in 5 stages: the business problem and data context, the data preparation and modeling process, model evaluation and key insights, model challenges and recommendations, and short personal reflection and conclusion. Let's start with the business context. The bank was running large-scale phone marketing campaign to promote term deposit products. Thousands of calls were made to existing and potential clients, but most customers simply said no. This created low conversion rates and high operational cost. The goal of our analysis was to build a predictive model that could identify clients most likely to subscribe, allowing the bank to focus its efforts on high potential leads and improve efficiency. In short, we reframed the marketing challenge as a binary classification problem, predicting whether the outcome variable Y is yes or no. From business perspective, this model could help reduce wasted call time, improve conversion rates, and support data-driven marketing strategy. From an academic view, it shows how analytics can turn operational data into insights and action. Moving on to the next slide, dataset overview. Our dataset came from a Portuguese banking institution and is publicly available in ICI Machine Learning repository. It contained 45,211 records and 17 variables in total. The data covers demographics, age, job type, marital status, and education, campaign details that include call duration, previous contact outcomes, contact type, and campaign month. Third is socioeconomic indicators, employment rate, CPI, and Euribor 3-month interest rate. The target variable Y indicates whether clients subscribe to a term deposit. Because this dataset combines behavioral, demographic, and economic variables, it offered a rich base for predictive modeling. However, the data also contained missing values, categorical variables, and a strong class imbalance. Only about 11% of outcomes were yes. We had to address these issues before building any model. This slide is about key data insights. During exploratory data analysis, several important insights emerged. First, the class imbalance. Only around 11% customers subscribed, highlighted that the bank's marketing was reaching many people who were unlikely to convert. Second, age. Clients aged 40 to 60 showed significantly higher subscription rates than the younger ones. Third, call duration was strongly correlated with positive outcomes. Longer, more engaged conversions tended to end in yes. And finally, economic conditions influence decision. When Euribor 3-month rates were low, customers were more willing to lock in term deposit. These findings give us a strong conceptual foundation. The success of a call depends on who you call, how you engage, and when you do it. Moving on to the next slide, the data preparation. Arguably the most time-consuming and critical phase. We began with data cleaning, removing duplicates and replacing missing values. Categorical variables such as job, marital status, and education were converted into numeric form using hot encoding. Continuous features like age, balance, and duration were standardized to ensure equal weight across models. To tackle the imbalance between yes and no outcome, we applied SMOT, synthetic minority oversampling technique, which generates synthetic examples of minority class. Finally, we split the data, 70% for training and 30% for testing, to measure true model performance on unseen data. The result was a clean, normalized, and balanced dataset ready for modeling. Moving on to model development, we developed and compared 3 machine learning models: decision tree, random forest, and k-nearest neighbors. The decision tree was our baseline model. simple and interpretable but prone to overfitting. The random forest, an ensemble of many decision trees, improved accuracy and stability by averaging multiple predictions. Third, the KNN model was tested for comparison, but it performed less efficiently with large datasets and mixed features. After parameter tuning, cross-validation, random forest outperformed others in both accuracy and generalization. The confusion matrix on the slide shows that model correctly identified most non-subscribers while capturing a reasonable portion of actual subscribers, a balanced trade-off for real-world marketing. Moving on to the slide, model performance comparison. Here's how the models compared across key metrics: accuracy, precision, recall, F1 score, and ROC AUC. Decision tree achieved about 82% accuracy but was overfitted. Canaan performed lower, around 80%. Random forest scored most among these, which is around 85% accuracy, with the highest recall and F1 score. High recall is especially valuable in marketing because it means the model successfully captures most of the customers likely to say yes. The random forest model also provided feature importance scores, which helped us interpret the drivers behind customer behavior. In summary, random forest was chosen as the final model for its balance of accuracy, robustness, and business interpretability. The random forest model gave us deeper insights into which customers were more likely to subscribe to a term deposit. We found that age and call duration were two strongest predictors. The economics context also played a key role. When the Euribor 3-month rate, which reflects short-term interest rates, was lower, campaigns tended to perform better, probably because customers were more willing to invest. And more engaging phone conversations were far more likely to get a yes as well. We also saw that customer relationship factors such as whether they'd been contacted before and the type of communication, cellular versus unknown, influenced success. Altogether, these insights help the bank improve targeting strategies, resource allocation, and campaign timing, leading to stronger returns and more efficient marketing. Now looking at model evaluation, the random forest model achieved the best balance between accuracy and recall, with an AUC of around 0.73, which indicates a reliable level of predictive performance. It effectively identified clients who were most likely to subscribe, supporting more targeted and data-driven marketing strategies. However, we did notice that precision was modest, meaning that some customers were predicted to subscribe but ultimately didn't. A reminder that while models are helpful, human judgment is still important for follow-up and engagement. From a business point of view, this means marketing teams should focus their follow-up efforts on this predictive positive to convert more leads. The model can also reduce campaign cost by narrowing outreach to promising leads. And it highlighted how features like call duration, age, and past campaign outcomes are strong behavioral indicators that marketing managers can act on. To conclude, the random forest model provided the most balanced and reliable performance out of all the algorithms tested. The analysis confirmed that call duration, age, previous campaign outcomes, and economic indicators such as Euribor rate were the strongest predictors of customer behavior. From a business perspective, these insights can help banks enhance marketing efficiency, improve targeting accuracy, and ultimately increase subscription rates while reducing operational cost. For future work, it is recommended to exploring SVM XGBoost, which may offer higher recall and better interpretability. It is also suggested to implement real-time dashboards for campaign managers, addressing class imbalance using more advanced resampling methods like SMOT, and integrating more granular data such as digital interaction patterns to personalize marketing even further. Before wrapping up, I'd like to share a brief reflection of what I personally took away from this project. Working on the bank marketing campaign analytics project really deepened my understanding of how data driven decision making can transform traditional marketing. It was eye opening to see how models like Random Forest can uncover hidden behavioral patterns, insights that can directly support smarter business strategies. I also learned the importance of collaboration in analytics project. Each member of our group contributed different strengths from data cleaning and modeling to interpretation, and this experience taught me how crucial communication and version control are in shared data workflow. On a technical level, I gained confidence in model evaluation and understanding how to interpret accuracy, precision, recall, and F1 scores in a real world based context. Overall, this project gave me a strong appreciation of how AI and analytics combine both technical skill and business reasoning. Thank you so much.